What if I told you that the device in your pocket today is more powerful than entire communication systems from just a few decades ago? If you enjoy simple and clear explanations about technology, make sure to like, subscribe, and share this video to support the channel. 1G, or first generation, came out in the early 1980s. This was the first time people could call someone wirelessly. Before that, phones were connected to cables, meaning you could only make calls from fixed locations like homes or offices. That made communication limited and inconvenient. 1G used analog transmission, which converted your voice into radio signals and sent them through the air. Even though these phones were portable, they were large, heavy, and very basic. They were designed only for voice calls, with small screens mainly used to display numbers. However, 1G had several major problems. Call quality was often unclear because analog signals picked up noise and interference. There was no encryption, so calls could be intercepted using radio scanners. Battery life was also very limited, often lasting only 20 to 30 minutes of talk time. Because of these issues, a better system was needed. 2G arrived in the early 1990s and introduced digital communication. Instead of sending voice as analog signals, it converted it into digital data. This made calls clearer and more secure. It also introduced SMS text messaging, allowing people to send short messages without making a call. 2G also brought early mobile data. The first version, GSM, had speeds around 14.4 kilobits per second, which was extremely slow. Later upgrades improved performance. GPRS increased speeds to around 80 kilobits per second, and Edge pushed it up to about 200 kilobits per second. Even with these improvements, internet browsing was still difficult. High latency caused delays, and websites had to be typed manually. As internet usage increased, 2G could no longer keep up. 3G was introduced in the early 2000s as the first network designed for internet use. It allowed users to send emails, browse websites, and access early social media platforms. Speeds reached around 384 kilobits per second, a significant improvement over 2G. Later upgrades such as HSPA and HSPA Plus increased speeds to around 5 to 10 megabits per second. This made it possible to watch early online videos and make basic video calls. However, performance was often unstable, especially when many users were connected at the same time. Content frequently had to be viewed in lower quality due to these limitations. As applications became more advanced, a faster and more stable network became necessary. 4G, also known as LTE, was introduced around 2010 and marked a major shift toward modern smartphones. It was designed with internet usage as the main priority. Speeds typically ranged from 10 to 100 megabits per second, with later improvements reaching up to 300 megabits per second. This allowed for high-quality video streaming, fast file downloads, and smooth online gaming. Devices also changed significantly during this period, moving toward large touchscreens instead of physical buttons. This shift was driven by the need to support more complex applications such as navigation, video calls, and interactive platforms. 4G networks were also more efficient at handling many users at once, making them more stable than previous generations. However, in crowded environments, performance could still decrease due to network congestion. 5G began rolling out around 2020 and is now used in many modern smartphones. It offers much higher speeds, reaching hundreds of megabits per second and even exceeding 1 gigabit per second in some cases. In addition to speed, 5G significantly reduces latency, typically to around 15 to 30 milliseconds. This allows for faster response times in applications that require real-time interaction, such as online gaming and navigation. It also enables advanced uses like controlling drones and streaming live video with minimal delay. Despite these advantages, 5G coverage is still expanding. In many areas, especially rural regions, devices may still rely on older networks. For most everyday activities, previous generations remain sufficient. 6G is the next stage of mobile network development, but it is not yet available for consumer use. It currently exists in research environments, including laboratories, satellites, and experimental infrastructure. In theory, 6G could reach speeds of hundreds of gigabits per second, with some experimental results approaching 1 terabit per second. It is also expected to integrate artificial intelligence to optimize connections, predict network demand, and manage data traffic more efficiently. Rather than focusing only on smartphones, 6G is expected to support large-scale systems such as advanced automation and scientific applications. Based on current trends, it may become available to consumers around 2030. Even with these future developments, current networks already meet the needs of most users. Everyday activities such as messaging, streaming, and browsing can be handled efficiently without requiring the highest available speeds. Thanks for watching. If you found this video helpful, make sure to like, subscribe, and share it with others, and check out the channel for more simple and clear tech explanations.